you will learn about an easy way to make a classic snake game in 60 lines of code using the Python language in the PyGame library. So take a closer look and let's code. So the first thing we need to do is install the PyGame library. So in the terminal we enter the command pip install pygame. Now we import this library, and we also need the randrange function from the random module. Let's define a variable for the window size, create a screen rendering surface of the given resolution, and create an instance of the clock class to set the frame rate. Next, we create the main loop of the program, in which at each iteration we first check for closing the application, then we paint our surface black. Then we need to update this surface and set a delay to determine 60 frames per second. Now you can run the program and make sure that a window of the specified resolution is created. Since the playing field will be in the form of a grid, we will define a tile size variable. At the same time, let's define the range variable. It will be a tuple that will define the range for the random coordinates of the tile centers on the grid. And then using this range tuple, you can create a getRandomPosition function using the imported randrange. Now you can define the parameters of the snake. First, let's define the head of the snake. It will be an instance of the rect class, and also let's define its random position on the grid. Then we define a variable for the length of the snake and define a list where all segments of the snake will be stored and put the first segment there as a copy. And now you can display a snake. For this it is more convenient to use a list comprehension in which we will go through the list of segments and draw each segment in green using the drawRect function. Let's run the program and make sure that our snake is displayed correctly, and as you can see, every time you run the snake appears in a random place on the playing field. In order for the snake to move, we define a variable for the direction of the snake. So, in order to change the direction of the snake, we will write a control for 4 WASD keys. We will check the event for pressing one of these keys and then change the direction of the snake, given that the snake step is equal to the size of the tile on the grid. Now you can move the snake's head using the moveInPlace function, while at each step we add a new segment and cut the list of segments along the length of the snake. In other words, we record the entire path of the snake and leave the last steps by the length of the snake. Let's look at the result. As you can see, now we can control the snake, but there is one problem. The speed of its movement is too high, and now we need to implement a method to control the speed. To do this, we need two variables, time and timestep. Timestep is the delay between snake steps in milliseconds. Then at each iteration we will track the time interval, and as soon as the value of this interval is greater than the time step value, then the snake will take the next step. If you look at the result, then in this way we got a way to control the speed of the snake. Now let's define the variables to determine the food for the snake. Let's make the food variable as a copy of the snake's head and also assign it a random position on the grid. And to draw food, we use the same drawRect function of the PyGame library. So now we have two elements in the game, a controlled snake and food. Now we can move on to coding their interaction. To do this, just check the positions of the snake and food. If they match, then change the position for food and increase the length of the snake by 1 unit. Let's look at the result, and as we see, the snake eats food and increases by 1 segment. Everything works correctly. And now we will implement a method for checking if the playing field is out of bounds. To do this, It is enough to check the coordinates of the sides of the snake's head with the size of the sides of the window. We do this along the x-axis and along the y-axis. If the snake has gone beyond the playing field, then set the snake and food to random positions, reset the direction of the snake and reduce its length to 1 unit. Now you can make sure that everything is working properly, and when you go beyond the boundaries of the playing field, our game restarts. If we play a little and grow the snake to a certain length, we see that it passes through itself, but this should not be. Eliminating this shortcoming is quite easy. We use a function to check if the snake's head collides with the rest of its body. Write this into a separate variable self-eating. It will be true when a collision is detected, and add this variable to the general check. Let's play our game again and let's grow the snake to a certain length. And as you can see, this method works great. The game restarts when the snake eats itself. And in order for us to get a full-fledged game, we need to prohibit the snake from moving in the opposite direction. To do this, we will define a dictionary in which for each control key the prohibition of movement will be determined. Initially you can move in any direction. When we press one of the keys, we first check the permission to move in this direction, and if it is possible to move, then we rewrite this dictionary where it is already forbidden to move in the opposite direction. We will do the same for all other control keys. And then, as a result, we created the classic full-fledged snake game in 60 lines. Of course it can be less, but the readability of the code will be lost. But in the end, it turned out to be quite easy to create a snake game using the PyGame library. Subscribe to the channel. See you soon.